Welcome everyone. Today we're going to be covering the topic Azure Cloud Services for Data Engineers. My name again is Tom Kinser. I'm a Microsoft certified trainer, have been since '95, teaching primarily software development and also as a consultant in building applications for the healthcare industry for both the provider, payer side. More recently, of course, with the explosion of Azure, and cloud services. A lot of exciting things are happening in the cloud, and much of the work that we've been doing locally, on-prem, within our own data centers, is of course shifting to the cloud. And one major area here is the tremendous amount of power that you will now have available to you in the cloud for analyzing data. I also have a background in working with Tulane University out of New Orleans, when many of the physicians were doing fellowship residencies here in Georgia. I work with many orthopedic surgeons for doing data analysis on medical procedures. If we had tools like we have now, that would have been much easier. It was difficult a few years ago, but now we have tremendous amount of scalability, availability with cloud services. So what we're going to do today in this seminar is we're going to cover the current Azure services that can assist you in setting up an environment for your data scientists and your data analysts. So you're going to look at the tools as a data engineer. So we want to be clear about those different topics. This is more about provisioning and setting up the infrastructure or platforms to provide access to your data, to analyze, investigate, visualize the data by your data scientists and analysts. This seminar is brought to you by WebAge Solutions. You'll see the website there, webagesolutions.com. I've been working with WebAge for several years, many years, as an instructor. So let's go ahead and get started and see what are the different services that are available in Microsoft Azure to support your data engineering needs. Quite a few of them, and we're going to cover them in this order. And you'll notice as we go through this, there is some overlap between the functionality of some of these products. So we're going to start with the most fundamental, basic service, and that is an Azure Storage Account. We're going to see what is an Azure Storage Account, what are the different variations of how you could use it, and how could I set it up as a data lake. Then we're also going to look at relational databases in Azure SQL Database. What is this service? How is it similar to SQL Server? Because it's not actually SQL Server, but we'll see it's an excellent target for migrating your SQL Server workloads to the cloud. We'll also look at NoSQL databases, non-relational databases in CosmosDB. It has 5 different APIs that can support 5 different ways of managing your NoSQL data, and we'll go through demonstrations for this one as well. We'll also look at the data factory. What is the purpose of the data factory? What is, how will that fit in with your data engineering needs, primarily to move and transform your data? So whether you are using tools for ETL or ELT, that's extract, transform, and load, on-prem, other tools, maybe other cloud services, you'll see where the data factory can help leverage even these other services to move or transform the data. And then we'll focus in on Databricks, which is an Apache Spark-based cluster that allows you to work with your data, analyze the data, and even perform ETL within Databricks using Apache Spark. And then we're going to look at the new Synapse Analytics, what used to be called SQL Data Warehousing. Synapse Analytics goes beyond just simply a hosting environment for a data warehouse. It now incorporates the same functionality in both SQL databases, Data Factory, and Databricks all in one place, as well as streaming analytics. So Synapse Analytics has the goal of trying to consolidate a lot of this different functionality that is available in multiple services under one interface. So we'll take a look at Synapse Analytics as well. Now, to work with real-time data, there are two services that you need to be familiar with, and that is the Azure Event Hubs service that allows you to capture millions of events and related data per second from anywhere and publish it for any subscribers. So it is a point of ingress or pulling content into your environment, into Azure, and how you and where you send it or how it's published could be very open-ended. It also could drop the data right into a data lake. It has features to do that automatically, but the Event Hub has no storage. It is basically capturing the data associated with an event and sending it on to interested subscribers. And then the IoT Hub is similar, but has more functionality and capabilities to work with IoT devices. Where the Event Hub is a single direction of flow of data, IoT Hub is bidirectional. So data can flow in from your IoT devices, and you can send data configuration information back out to those devices. Plus registering devices, recognizing a legitimate device that we're going to accept data from. All of that's built into multiple subservices of IoT Hub. But both of them are capturing data, but not storing the data. So with both of the hubs, the data must be passed on to another destination. But while it's being collected, that last point we're going to look at too is stream analytics. Stream analytics lets you connect to a streaming set of events in the data, such as what comes from event hubs or IoT hubs, and performs real-time analysis on the data in real time. So we'll see how does that work? How do you set up a stream analytics job to inspect or intercept the data coming in through one of the hubs, the event hub or IoT hubs? Stream analytics can also work with your storage account in case it needs to look at static data that may have been recently stored. So sometimes that's referred to as near real time, pulling data out of your storage account or your data lake. So those are all the topics for today. We've got about 3 hours to go through these topics, and hopefully I can demonstrate as much as possible so that you can be comfortable with these products. Just as a show of hand, trying to determine how much detail I can go into each one of these. How many have worked with Azure already? Can you just give me a show of hands if you're already working with Azure services, any of these products? You have a raise hand feature there in this interface, the GoToWebinar interface. Or if you, I'm not sure if you can use the chat. I'm not sure if that's been disabled as part of a webinar, but feel free to put comments, or you can attempt to type in comments as we go through this class. And then later too, we will have a Q&A session for any one of these. But at any time, if you have questions, please post them, and I'll get to. Oh, question is recording after today. Maybe I missed the whole thing. Oh, great topics would be getting the presentation deck. You should already have received the presentation deck, or they may be waiting for a full roster. And you should have access to the recording, yes. All right, so again, please post any questions you have. I'll try to get to them as quickly as possible and as many as possible. So let's get started, and I'm going to use an account in my Azure account in order to demonstrate each one of these. So let's start with the storage account. The original Azure storage account is rather flat. So when we refer to original blob containers in this slide, we're really talking about containers that have no hierarchy. If you were to activate the hierarchical namespace in blob storage, you will have created a data lake. And that's the only difference as far as configuring whether you want the original flat storage account or do you want a data lake. Now, when we create a data lake, we're actually making the data lake or the data storage itself Hadoop compatible, which means that we can work with both Hadoop, Spark, Databricks. So from the standpoint of a data engineer, you probably more often than not are going to enable the hierarchical namespace. The screenshot that's shown on the right in this slide shows where that setting is. It's in the Advanced tab, and what's highlighted in red, you'll see it says Data Lake Storage Gen 2, and the hierarchical namespace by default is disabled. And when you enable it, you're actually creating an Azure Data Lake Storage, which means too that it can have directories and folders within it. The original blob containers do not allow for folders and containers to be created through the UI. And so you have just lateral containers that can contain any number of files, but they just don't have the hierarchical structure. The original blob storage was not Hadoop compatible, but many of the tools that we use now, including Azure Synapse and Azure Databricks, can work with the original storage, but you'll get much better control and higher compatibility of other features if you go ahead and enable hierarchical namespaces. In fact, if you think or you suspect you may ever use a storage account with Databricks, Event Hub, Synapse Analytics, it would be an advantage to enable the hierarchical namespace. And as of today, currently, there's no difference in charge. Now they do charge separately for each, but currently right now it's the same charge. So that means they may have different charges, for original blob container versus data lake in the future. But as of right now, there is no difference in the cost. Now, when you create a storage account, you also are creating 4 possible storage types: blobs, file shares, tables, and queues. But it's the blobs that has the flexibility to be generated a certain way or configured a certain way when you first create your storage account. Now, in the United States and Europe, as of today, you can have up to 2 petabytes of data per storage account, which is a substantial amount, and you can create hundreds of storage accounts. So this is one of the most typical fundamental services that's initially created when you're starting your own solution, is to at least have one storage account or a couple, and each of these have a physical location somewhere in the world. So when you set up a storage account, you usually have to determine where is the best location in the world for this data, depending on how it will be used. You should try to co-locate your services within the same regions as much as possible to try to minimize the network latency for not only your services that are working together in the cloud, but also where your customers are, where your external applications and users are to access the data. So whether it's West US, East US, Brazil, Europe, Japan, you choose the location of your storage account. Now, every storage account is automatically encrypted wherever you may put it. It's also automatically replicated. However, you have an option of how it is replicated. You have multiple options for whether it's going to be locally redundant, which means it's replicated within the same data center, within the same building, or it could be replicated within the same region across multiple zones of that region, or different regions. Now, when you set up a storage account, everything in the storage account has one original location, and then if you replicate by zone or geo replication, then it will be automatically located in a predefined place. For example, if you say you want to put it in East US, it will automatically be replicated in West US if you enable geo redundancy. You don't have any control necessarily over what that other location is, except by how you set the redundancy. So it can be locally, zone, or geo redundant. And when it's also geo redundant or zone redundant, you can indicate that you would like to read the replica. You cannot write to the replica, but you can have a read-only copy or read access to that replica for the whole storage account. Now, file shares also can contain the same files that you put in blob storage. However, they're designed to be shared. So a file share is designed to be leveraged with SMB for sharing across a network. So if you had a VM running in the cloud, you could map a drive to a file share, say your J drive or your K drive. It's very common to do that on-prem, mapping a drive letter to a network file share. Well, this is a cloud file share that behaves exactly the same way, that you simply point to the URL of the file share, and then it can be mapped to a drive letter from your VMs or even from your machines outside of Azure. The tables services, storage service that's built in, or storage type, is a NoSQL storage, which means the tables are not related to each other. There's no way to have, for example, a foreign key in one table pointing to another table. It is strictly storing what are referred to as entities. Now, it can be indexed by a partition and a row key, but there is no correlation or relationship between any entries or entities within these tables. And they do have a place. In fact, we'll see it also implemented in CosmosDB. And we'll see what the difference is, why you would choose this maybe over CosmosDB or vice versa. And then the last, definitely not the least, is support for queues, which is a single direction message queue. Component can write to the queue, and then we expect some other component or application to read from the queue. So it allows you to create loosely coupled scenarios where one application can write, let's say, orders coming over the web. We put all of our orders or tickets into a queue, and then we're done, expecting another component or multiple components to read that queue and process as fast as possible whatever is pending in that queue. But when we're talking about data engineers and data scientists, the primary focus here is going to be back on that blob storage. That blob storage is going to act as the basis for many of the things that you may need to do within just collecting the data, processing it, preparing it, maybe as a work area. Think of it as a scratch pad where we might be working with data or holding the data until we can clean it up and maybe load it into a relational database or into a data warehouse. So not only is the data lake usually the initial storage of a lot of your data, but it can also be an intermediate storage in an overall process, and maybe even the ultimate final storage, especially for binary data like images, sound, videos, etc. So let's create one of these. I'm going to bring up my browser, which I didn't have already started. And let's see, let's go into, got multiple accounts here. Got my Microsoft Live account. Now, if you're brand new to Azure, what we just did is we came into portal.azure.com, and now I'm on the home page. In order for you to do anything within Azure, you have to have a subscription. So the home page is showing that I'm using my account that comes with an MSDN subscription, which includes a monthly credit that I can use to experiment and develop with. Now over here to the left, we have the first four options are fixed. Create a resource, go to your home page, bring up a dashboard, or go to all services. Now, at first you may see, what is a resource versus a service? But when you click on all services, you're going to be given a list, categorized list of services that can be used. And you'll notice here, if I go to categories all, I can see every service possible that I could use within my subscription. Now, that doesn't mean it's allowed, but it's saying here is what you may want to try if your administrator of your account allows it. But you can see it's a long list, and you'll see how many things are in preview. That's a constant state, that there's new previewed services coming out all the time. Now, along the categories, this can help filter it. So for example, if I go down to what are my database services? How can I perform analytics? And between these two and let's see what else, storage. There it is. Those three areas, storage, databases, and analytics, are really where we're going to find most of the services that we're going to talk about. But you could, if you know the name of the service, simply type it in under all services, or even higher up, you can type in the top search bar across all of Azure. So we're going to do a storage account. Now, I could use the all services to find storage accounts, but you can also put storage accounts in your favorites by clicking the star in the pop-up view here, a solid blue star in this case, because the color may be different in different themes, but the blue solid star means that it's listed over here under my favorites. So all of your favorites here are under your control. You can sort them, you can remove them, you can add new ones, but here's storage accounts already in my favorites. Now, to move your favorites around, there's a handle, the a vertical ellipses, vertical three dots, shows I can grab these and move them around any way that I want. Now, a service is a potential resource. So when I go under storage accounts, I see I have no storage accounts. Or if I were to look under all resources, I've cleaned them all out. So I have a totally empty subscription. I'm not being charged for anything. So a resource means you have provisioned a service, and now you are committed to using this resource or deleting it at some point. But usually a resource means you are paying for a service. So that's a subtle distinction. Service is a potential resource. A resource is what you provision and what you're paying for. So if I go to a specific service like storage accounts, I'm going to create a storage account that will become a resource. Now, in this interface, these windows are referred to as blades. These blades are letting you interact with the current resources that you have available, or to reconfigure resources, set options, etc., to interact with Azure. So when you go in and create any or provision any resource, you always have to indicate the subscription. How are you going to pay for this? The resource group is a logical container to help you manage the resources. So I'm going to try to use one resource throughout the whole seminar today, webinar. So I'm going to create a new one, and we'll simply call it Demo RG, Demo Resource Group. Click OK. And all that is a logical container. So when this webinar is finished, I can just delete the resource group, and it will delete all the resources that we've created today. What is my storage account name? Well, this has to be unique worldwide within Microsoft's network. So it must be lowercase, because this will create a URL that will be accessible over RESTful calls. In other words, you can use HTTP verbs, get, post, put, etc., to interact with with your storage account. Oh, it looks like it's already been taken. Let's see. Let's just call it, well, let's see if demo is taken. Okay, well, it's not telling me one way or the other. All right, JTK demo. Let's just use today's date. That's a common fallback. I call it 0507, today's date. And then where in the world do you want all of this data to be kept? Now, a resource group also has a location, but it can be different from the resources that are in it. So the location of a resource group is going to be just where is the metadata, which is a very small amount of data. And then the region here is where are you going to store the data. And remember, if I choose a US or a Europe location, I could have up to 2 petabytes. Any other location anywhere else in the world is still, let me get this right, 500 terabytes. So still substantial. But over time, every location or every region will be adjusted for higher capabilities. So eventually, usually things are introduced maybe in West US and East US and Europe, and then eventually spreading out, or they'll introduce new services immediately in a new data center somewhere in the world. These data centers are coming up constantly, all the time. In fact, we're getting one here in Atlanta, Georgia. It'll be East US 3. Phoenix is getting one too this year. Phoenix, Arizona, it'll be West US 3. They're popping up all over Europe, Asia. South America currently only has one, but should be getting more within Brazil and other countries. So the drop-down list is going to show you some of these potential regions in the world, but the list may not be all the locations. It's typically filtered by where is this service supported. So don't view this as a complete list. Microsoft, of course, has a map and a list of these at azure.com. So we're going to stick with East US as a good practice. Now, East US tends to be overutilized, and sometimes you'll get a recommendation to use another location, East US 2, or both East and West US are heavily used. So what kind of performance do you want? Well, when you see premium, you of course say, well, definitely I want the fastest, the best storage possible, but there is a trade-off. Notice it says standard is recommended for most scenarios. And the reason for that is because of the redundancy capabilities. If you're going to replicate your data in another location in the world, then geo-redundant eliminates premium. You can't have both. You cannot have geo-redundant and premium. So notice if I change to premium, it's going to eliminate the total, all the network latency, because it's going to keep it within the same building. And that means your redundancy choices are locally redundant only. That's it. The problem with locally redundant is if a data center goes offline, you don't have access to your data. Even though there's 3 copies in that data center, the whole data center went offline, you're not going to be able to get to the data. Now, it doesn't mean it's permanently lost. It's just not currently available until they recover it. But if you use standard, with standard, not only can you make it locally redundant, but I can spread out to geo-redundant or zone redundant or geo-zone redundant. So at least with geo-redundant, which is the default, it allows you to move your data into 2 totally separate regions, usually thousands of miles apart, if possible. But it does try to keep it within the same political geography boundary. The one exception is Brazil. Brazil's geo-redundant copy is in the United States. Most other regions have another location within the political boundaries to keep the data within that by default. Now, I'm pointing this out because when we start looking at CosmosDB, CosmosDB lets you choose any location in the world and as many as you need to support. So whether you have 2 copies, 5, 10, I can put them in every data center in the world, and all of them are synchronized with each other. But of course, CosmosDB is a more powerful service, so it comes with a slightly higher price tag. And if you don't need it, then maybe staying with storage accounts might be the most cost effective, but you have the choice. It's up to you. So with storage accounts, you can have geo redundant, but you do not have a choice of that second location. And I'm going to demonstrate that in just a moment. All right, so now this is going to be, oh, you know what? Let me, yeah, we'll just call that, I think I want to call this storage because I want to distinguish it from a data lake. So JTK storage 0507. I'm not going to go, go into each one of these yet, but I wanted to point out, here is where under the advanced tab, we have enable hierarchical namespace and it's not selected. So that means I am not creating a data lake. All right, so let's see if I've answered. If you have an asterisk next to each one of these, you have to complete it. Let's see. Oh, and here with network connectivity, you're allowing public endpoint. That means all networks, including the internet, would be able to access this storage account. And let's see, data protection. Basically, some of the other options that are available to you with a storage account, such as soft deletes, are automatically enabled in case you accidentally delete a file. You've got this recycle bin with soft delete so that you can bring it back, and you can just determine how long do you want to keep deleted blobs in case you do need to recover them. And notice too, we also have soft deletes for file shares. We can turn on versioning for blobs. We can keep up with what are called blob change feeds. Now, I'm not changing any of those. I want to keep it to very simple as possible. Now at the top, it's running a validation. As soon as everything appears to be okay, then I can select create. So this is creating a storage account, but it's not a data lake. This is usually referred to as the original blob storage or shallow storage, but it still can prove to be very handy. And the data lake is going to introduce other features, which I'm going to do next. So now while that's deploying, I can go back to storage accounts. Even though the first one is not finished yet, I can create a second one. And I'm going to go through this a little bit quicker. Same resource group, but this time I'm going to call this one JTK Data Lake, and then use today's date, 0507, East US standard, geo-redundant. And remember, the only difference between this one and the first one is not only the name, but I'm going to check this box, enable hierarchical namespace. And notice what it's under. It's in a data lake subcategory here. This, and what it states here is true. It accelerates big data analytic workloads and enables file level access control lists. Without it, you still could take advantage of the same amount of storage, but it would not be Hadoop compatible until you enable this, and you would not be able to use some of the features that are built in now to Synapse Analytics and Databricks and how it expects to locate the data. And then there's several others. Notice one too, I want to point out, with blob storage, you also have what's called an access tier. It defaults to hot, which means this data will be frequently written and read. So what that provides is a cheaper access charge, but slightly more expensive storage compared to cool. Cool means it's infrequent, so the storage is cheaper, but the access charge is higher. And then there's a third not mentioned here because you have to deliberately put it in a third level called archive. And archive is the cheapest of all storage, but it can have the highest penalty if you access it too often. So for cool, the limit is 30 days. If you're not going to work with data more than once every 30 days, then cool would be an excellent choice because it's much less expensive for storage. Archive is 6 months. If you put something into archive, you are basically committing to it being offline, and you're not going to access it within 6 months. So that's the cheapest of of all the storage types, but it's intended for very little infrequent. It's intended for infrequent access because you will be charged more if you try to access or reactivate archived data too often. So that's why hot is probably the most typical initially with your data, because it's what you're actively using, reading and writing. But don't forget that you do have these access tiers that you could gradually move your data out to cheaper and cheaper storage, as long as you can commit to the fact I'm not going to read and write to it very often. And then we can go to networking. Well, let me make sure that I've got the hierarchical. Yeah, make sure that's there. Not changing any of these other options, are all the same as the first. And then I'm going to run validation on this last page and double check one more time that, let's see, where is it? Right here. Enable hierarchical namespace is enabled. Now that's not an obvious setting. It would be nice if it just said data lake, but hierarchical namespace is the same as a data lake in Azure storage. And we create. So now we're going to have two storage accounts. One that would be standard storage. I usually refer to it as flat because it has no hierarchy. And we have a data lake that will be used for hierarchical. And we're going to hold on to this for the rest of the demos, because this is a base service that we could use over and over again with the other services. So give that a few seconds to complete. There we go. And if I go back to my storage accounts, I should have two listed. Let's refresh this. All right, the other one hasn't showed up yet, but let me go ahead and demonstrate under this standard storage account. They've recently changed the UI, but it still gives you the same information. So for example, you see listed vertically, we have blob service, file service, queue service, and table. Right at the very top of blob service, the most important setting that you'd want to know as a data engineer is it a data lake or not? Hierarchical namespace disabled, so it is not. But we could go in and work with all four types of storage, as long as we don't expect to use this with Hadoop or to expect folders within your blob service. Now I can also review what's in all four of these with the Storage Explorer, or over here under the data storage menu section, I can go directly to any one of the four. So let's go to containers. If I navigate to containers, that means I'm in blob storage. It has already, and this is a new default, created a container for logs so that I can keep track of what's happening not only within this service, but I can send other logs to this storage account. But I'm going to create a container, and we're going to call this images. I'm going to upload some pictures that I'm going to make available to all of you so that you can see how easy this is to get to data in an anonymous fashion. This is the only storage type in a storage account that allows anonymous access, and it's anonymous read access. Hold on just a second. Let's see if I got some other questions here. No. Okay, good. Okay, so I'm going to set this to anonymous read. I'm going to create the folder, and then I'm going to navigate into this, I shouldn't say folder, container. I'm going to navigate into this container, and you'll notice here there's no action here to allow me to create a folder or a directory. It's just a container that has no depth. It's very flat. In fact, shallow, you could say, and it can contain any number of files. In fact, I could put all 2 petabytes of data in one container if I wanted to, but you're using up the potential or the capacity of the whole storage account. All right, so I'm going to upload. I'm going to choose files from my local machine. I've got all these pictures. I'll select off of my local desktop, open, upload, and it's going to create a series of asynchronous copies. All of the files are being loaded into this container from my desktop up into the cloud. And as it does that, it's going to, of course, list and show me when these were uploaded. And then any one of these, let's see, let's go with clouds over Portugal. If I select this file, it's going to take me to the metadata of the file, and I've got a copy. And notice that this copy is a URI. If I were just to drop this right into the browser, it's going to re-encode the spaces as %20, and then I'm going to drop this in the chat. And please just click that link. You'll notice that the format of that link is JTK Storage 0507. That's the name of my storage account, followed by blob.core.windows.net. That's fixed. That will always be that domain because that's Microsoft's domain that lets me have access to my storage account. The next part of the URL is the container name, images, and then the rest of it would be the file name. And if a file name happens to have spaces in it, then it will be re-encoded with %20. So any one of these names, just change that last part of the URL. For example, let me do coin, copy that one, put it up here into its own tab. And now I'm looking at a coin, an antique coin, 1882. So let me drop this. Since this had no spaces, it wasn't changed from the original. So click that. In fact, click these as often as you want because it's going to generate some metrics, some telemetry that lets me see which files are being accessed, how much data is being read, so we can monitor that later. All right, so there's a very quick and easy example of setting up blob storage using flat containers and then deciding whether I want to open up one container anonymously to the public with read capabilities, or it could be just a single file that's anonymous, or enforce other types of credentials if I kept it private. Now, I'm going to also switch now to the data lake. So under the storage accounts, there's my data lake now. So I'm going to go into the data lake, and you'll notice that it looks almost the same, but the label that used to say blob storage now says data lake storage. That is a huge relief. For years, it's been very difficult to see whether you're in a data lake or not, but now that it says data lake storage, that's much better. I believe that was changed just this week. So right at the top, it says hierarchical namespace is enabled. So I'll go into my data lake storage. I can either select it from here or the word containers. So the word containers is still used, but when you using a container in a data lake store, you're actually working with what are sometimes referred to as file systems. So the very root level, or however many containers you're actually creating multiple file systems that have nested namespaces or directories and folders. So the concept of a namespace is synonymous with folders and directories. So I'm going to create a container, and I'm going to call this my, I don't know, let's see, just data FS. And I'm putting FS on the end to indicate that this is a file system. I'm going to keep it private, but notice I do have the same capabilities of making my data lake public. Of each file system could be made public, but I'll just keep this in private, create. And then I go into my data FS, which is the name of the container, how it's managed. And now I can add directories. So let's just add a couple of directories here. We'll call this, I don't know, I'm just making up stuff here. Name one documents. Maybe I want to put document files in here. If I go into documents, I can create another level below it. Just like you're creating a file structure or a directory structure on a local machine, let's call this one contracts, as special types of documents or whatever. So I'm creating a hierarchical structure of folders. This was not possible within blob storage that's not a data lake, but it is now. This is going to become the most common way of working with your data if you're building or using a storage account for data processing, whether as a data engineer, how you're capturing the data through, say, an event hub. This is how you're going to collect the data, and then, of course, build as deep a level of structure as you want. Now, if I go back to my storage account, when you're navigating through the containers, you're only seeing where you are, but there is also the Storage Explorer that's built in. So the Storage Explorer has bring what used to be only a desktop product is now being presented as a user interface. So it still says it's under preview, but it works pretty well. I can go into containers. There's my data FS. If I select this data FS or file system, then notice it brings up over here to the right a way to navigate down through these different tiers, and it gives you what you refer to as a breadcrumb, data FS, down to documents, down to contracts, and then of course I could add files here as if it were a file share. Now, file shares are still there, but they're not, they don't have the functionality and the features of a data lake. So they're still separate. A file share is a separate type of store that can contain the same files as a data lake, but they're not going to be optimized for Hadoop or Databricks. So even though a file share can have the same files, the sole intent of a file share is to share this entire structure with other VMs or other applications. So file shares have always had the ability to show data in directories and folders. So I'll do a quick example here. I'm going to create a new file share, and I'll call it, I don't know, we'll call it my file share. I do want to keep it short. All right, so my file share, I'm not going to set a quote on it. Here's another example where we can use hot and cool and even transaction optimized. It defaults to that, so I'll leave it. Or I could just say hot, any one of these, and then create. I can go into my file share and notice it's going to look very much like a data lake in the sense that I can add a directory. So at the very first, I can say, you know, share this. So I'll create a root folder that I intend to share. And then maybe under here, I create yet another folder. I'll just stick to the same names. This is for documents. Under documents, I can create another one, contracts. So very similar, but for a completely different purpose. So if you want to share data, particularly across VMs and other machines, this is the tool to use. But if I'm simply collecting data, usually massive amounts of data coming in from systems or devices, then I want to use a data lake. So both of these storage accounts have all four types of stores in it. So both of these, whether they're the original storage account or the data lake, still have storage for blobs, files, queues, and tables. Now we'll come back around to table service later when we hit CosmosDB, because I want to show you the similarities between the two when we hit that. Okay, so that's a storage account. That's our basic starting point. Let's move on. SQL databases, probably the most commonly used type of store in the last few decades for business data. This Azure SQL database is a service that is to support relational databases. Exactly the way you may be using SQL Server or Oracle or Sybase or MySQL, this is a relational database store. This one, however, supports the same syntax as SQL Server for your queries, T-SQL or transactional SQL. It also supports transactional workloads, hence the name T-SQL. So that correlates back to what you may refer to as OLTP, online transaction processing. So it's ideal for daily transactions, a lot of reads, a lot of writes. It's not designed for reporting. And that's a big gotcha when we start trying to force SQL databases to be the source of your reports. They work well for small reports, but once you start collecting and archiving data, if you keep it in a OLTP type format, you're going to get very, very slow reports over time. So that's why you want to start looking at ways of moving this type of data into a data warehouse structure, like Synapse Analytics, which we're going to look at later. This is scalable because it's a platform as a service. There are no VMs that you have to work with. There is no virtual network you have to support. You do not ever have to update it. Microsoft keeps it up to date. And it's really the perfect migration target for any on-prem SQL Server workloads. You can move them to the cloud, and the biggest difference is the connection strength. Your applications can still continue to use the same T-SQL code to access this Azure SQL database. Let's create one. Go back to the portal. SQL Databases is in my favorites. I'm going to create a SQL database. Now, when you create a SQL database, notice carefully, it does not use the word SQL Server. It is simply a SQL database because this is not leveraging SQL Server. It behaves the same as SQL Server, but it's not an instance in the cloud. Now, you can still install SQL Server on a VM and host it in the cloud, but that's different than this. This is a platform as a service. So I'm going to choose a subscription, a resource group. I'm going to use the letters AW because I'm going to create a database called AdventureWorks. I'll just keep it a short name. And then here is looks like a contradiction. I said that this is not SQL Server, but now it's asking for a server. This is not the same as a SQL Server. This is a logical server, and I really wish they had labeled it that way, because this is the name of a server that's going to act as an administrative front end, primarily or initially a firewall. So I'm going to say yes, let's create a server, and we're going to name it, let's see if this takes JTK, just my initials. Okay, it's already used, 0507, today's date. And I'm going to give it an student is the name of the admin. Now, this is not leveraging Azure AD here. This is an internal administrative login just for this database, or for this database server. And we'll just create a password. So PA55W.RD is what I'm using. Keep it in the East US, click OK. And that's really going to create the firewall that my database is going to be protected behind. It also supports elastic pools, which is a way to share resources for two different databases. That can be beneficial if the databases are not in contention with each other, especially if they're accessed at different times of the day from each other. That would be a pretty good choice. But if your databases are very heavily used, it's not necessarily a good idea to put them in an elastic pool, because they may need to scale differently from each other, and they may need to have different levels of power. So you want to manage those separately from each other. Now, the next thing is, how much are you willing to pay for this? By how much computing power, how much storage do you need? It picks a fairly middle of the road, but it still could be more expensive than you want to use. So I'm going to say, no, I want to configure the limits on this database. And instead of, notice how it defaulted to general purpose, and it'll come up with a cost in just a few seconds after determining, yeah, so this is a $231 database per month. There's much cheaper ones, and there's also much more expensive ones. So I'm going to go back to basic, all the way back, and choose the cheapest one possible, and it's $5 a month. Notice all these different categories. A SQL database has one of the widest range of capabilities. I can go all the way up to $50,000 a month for a database. So choose the appropriate power that you need, and you can adjust it later. This is not fixed. So you can always scale up or scale back down depending on your needs. All right, so I'm going to apply that. And before I leave it, this would be an empty database unless I went under additional settings and said, go ahead and load a sample of data in order for this to already have data available. Review, let it go through a double check here to make sure everything looks good, and create. All right, got a couple of questions coming in. Can we upload a directory like files? Yes, you can in the storage container. In fact, that is actually a loophole. You could get around. You can't create a directory within the user interface, but you can upload a directory. So that's kind of a interesting way they allow you to get around that limitation within a storage container. Yeah, good question. Now, because I have never implemented a server before, it takes twice as long the first time because it has to set up the server and then a database behind it. And again, notice that it is still confusing because it says type is Microsoft.SQL/servers, but it's still not SQL Server. It is a server to protect your SQL databases. So you please be careful. Don't refer to this as SQL Server in the cloud. That would be a different implementation. That would be installing SQL Server on a VM and hosting that VM in the cloud. This approach, there is no VM that you have to worry about. In fact, this is actually running as a microservice. The point of creating a logical server is a connection point. We're going to see that in just a moment. You connect to the server to get past the firewall, and then you can choose the databases behind it. So you could create separate servers with multiple databases behind it. So yes, if you were creating dev, test, QA, whatever, production, probably you would want separate subscriptions for that, but you still could create separate logical servers for those different environments. Okay, let's see what's happening here. I'm gonna go into SQL database. Still nothing there yet. And this one takes quite a bit longer than a storage account, but we're gonna let that create and show you a few things about it. All right, let's see if the, well, I could go under resources to see if the server has been created. Yes, it has. So remember I called it JTK0507. And JTK0507 is my server. And again, I want to keep pointing this out because it looks like I'm contradicting myself, but right under that it says SQL Server. But notice it's a lowercase s. It is not an installation of SQL Server. It's a server for SQL. I really wish they could rename that so it's not as confusing. But again, the purpose of this is initially to act as a firewall. But I can also set other things about it. If you see over here to the right, I can also see what SQL databases are behind it. But when I go into the firewall settings, you'll notice that it doesn't allow anyone in. I cannot even look at the database. I can't even look at the data until I open the firewall for my IP address. So right now it's saying your IP address is 73.184 blah, 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 but there is no allowance for it. But to make it easy, there is an option at the top of the screen that says add client IP, and I could select this and it will put my IP address as a start and ending range. And that would mean only I can go into this database from this machine. If I went to another machine, I would be denied. But I'm going to blow away the firewall and just say entire internet. Give it a label, and then this is something I'm only doing for demonstration. This would defeat the whole purpose of having a firewall because I'm basically allowing every address. And I'm doing this in case you have SQL Server Management Studio, you'd like to see this database, you can connect to it. All right, so I save it. So I didn't just blow a hole in the firewall, I just blew it away. So this is going to allow all IP addresses to connect to whatever databases are behind it. Definitely not a good idea in the real world, but just wanted you to see how you can control that by IP addresses. Now, once the server has been set up, I can go say, well, do I have any SQL databases available? Yes, there's AW, it's now online. I can go to this database, and I can also query the database through the user interface, log in as student. Yeah, it's gonna ask for a certificate that's automatically created, which is fine. I go into the tables, I go down to say, customers, and let's see, does it actually create? Yeah, select top 1,000, just like SQL Server Management Studio does. And there's the data. Now I can also do it from my desktop. So from my desktop, let me go ahead and put this in the chat if you want to try it. If you've got SSMS or Visual Studio, you can, for the server, put in JTK 0507 database.windows.net. Then the user is student. The password is PA55W.RD, and then the database is AW. Those 4 pieces of data, and since I blew away the firewall, would give you access to this database from any tool that you may be using now for SQL Server. Will work exactly the same in the cloud. So if I quickly do that, I know we got quite a bit to go through here, so I don't want to, oops, let's see, SQL Server Management Studio. Yeah, there we go. Now, SQL Server Management Studio is a free product that you can download from Microsoft to your desktop. And because you didn't create this database, you don't have this blade to use the query editor. But if you bring up the Management Studio, then you do. And now this is updated quite regularly. Mine may be slightly out of date. Version 18.8, as you can see on the screen. And then once it's up, I can then connect directly to this database from my desktop. Illustrating the only difference is that we are now connecting up to the cloud, and we're working with the databases in the cloud. So give that a few more seconds. And you'll see that even though this tool was designed for SQL Server, it can be used for Azure SQL databases. They've made it as compatible as possible so that it makes it much easier for you to move your data from an on-prem SQL Server environment up to Azure SQL databases. And your developers or designers of apps, as well as maybe Power BI for that matter, could connect to this database in the cloud just as easily as it connects to a SQL database on-prem, just a different connection string. There are migration tools for helping you move your data as quickly as possible up to the cloud. And even if you are moving other tools, as infrastructure, those applications that you may be running on a VM could still connect over to a SQL database running in Azure SQL. All right, so here is the interface it usually defaults to. I'm going to change the server name to what I think I posted this correctly. Yeah, it should be in chat. It's jtk0507.database.windows.net. Now, it's not using Windows authentication, but this particular tool is not aware of Azure. Oh, yes, it is. But I didn't set up the database yet to work with Azure AD. So the alternative is use student as the login, or user as I put in the chat window, and the password is PA55W.RD. Yes, remember this password and connect. So that now will connect to the cloud. It will then look behind the firewall and say, okay, what databases are behind this firewall? And there it is, AW, the exact same database that I queried. And you can see this as well if you have this tool. If you download SQL Server Management Studio, enter those parameters, those credentials, and you'll see exactly the same thing. We will be working with the same database, showing you how quickly it is to make something in the cloud and make it available to whomever you need anywhere in the world. And here is the same table. Right click, show or select top 1,000, creates the query and executes it. Okay, that's the example of a typical SQL relational database in the cloud. So we've looked at blob storage for flat files or text files, binary files, images, sound, anything that you can think of really as a file can be loaded into blob storage. And if it needs to be relational, we can transform it, extract it, and load it in any order, really. Extract usually comes first, of course. Transform it or load it into a SQL database. How we do that, that's going to be some of the other services. But before we look at the other services, we need to look at another storage type. So I'm going to just close SQL Server Management Studio. I'll leave the database. Oh, I must have started it more than once. I'll leave that database out there though, so you can access it. So if I go to all resources, it shows that I've got an AW database. I've got a JTK 0507 server for SQL. I've got a data lake, and I've got a typical storage account. What's next? CosmosDB. CosmosDB is yet another platform as a service for non-relational, NoSQL database stores. It can be geographically replicated anywhere in the world as many times as you need if the location supports it. Now, most locations do, but I just have to throw in that catch because there could be some locations that don't support CosmosDB. Now, the original name of CosmosDB was only had one API in it called DocumentDB. So DocumentDB was the original implementation, and it only had core functionality. When they added 4 more APIs, they renamed it. So CosmosDB by itself is not any one type of database. It's just the name of the account type that you need before you can get to the other 5. So CosmosDB is not really a database, it's just a marketing name. You have to choose in CosmosDB, do you want its core functionality? Do you want a table? Do you want to leverage MongoDB, Cassandra, or Gremlin? Now, those last 3 are open source databases that have been implemented by Microsoft as an API under CosmosDB. So if you're using MongoDB on-prem right now, you could move that data up into CosmosDB and to continue to use the same syntax as how you might be managing MongoDB on-prem. Same thing with Cassandra or Gremlin. Probably the most interesting of all 5 of these to me is Gremlin, a graph database that lets you document or keep track of how data points are connected to each other. Probably the most typical example I can think of is think of a family tree. How are people related to other people? You know, by marriage, your cousins, your aunts and uncles, your ancestors. All of those could be easily identified in a graph database. This is a typical type of database that's used for social networks. You know, who are friends with other people? What documents are they creating? What groups do they belong to? So any type of connection information between data points is ideal for the Gremlin database as a graph implementation. Now we're going to look at just a few of these, but I wanted to make sure that you see what's similar between all of them, and of course, the differences in each API. So let's create some and show the difference. Go back to your Azure portal. CosmosDB can be in your favorites, or you can do a search in services. I have no CosmosDB account, and that's really the term. Remember, we called a storage account. We use that same word, account, but a storage account has in it 4 types immediately, blobs, tables, files, and queues. But when you work with CosmosDB, you have to have a separate account for each API. You don't automatically get all 5 APIs. So I'm going to create a CosmosDB account. Same questions pop up as you do with any other service. How are you going to pay for it? How are you going to manage it? They have a kind of a stretched out blade interface on this one. I don't know why, but all right. Then I'm going to call this a JTK Cosmos Core. So I'm going to use the core API, which is the default. Now, here's something else that's misleading. The word SQL is in parentheses. And I just told you this is a NoSQL database, and it still is. And that's why SQL can be confusing, because SQL in core only implies that you can use select statements. So select statements can allow you to query your documents. The data stored through this API is in JSON, JavaScript object notation. It is a document. So that's why it used to be called document DB. In fact, I think it might be a little clearer if we did say that in parentheses, JSON documents. But it does allow SQL queries, but it's still not relational. There are no foreign keys. So I'll demonstrate that as we go. So the term SQL is misleading because notice up here at the top, it still says this is a NoSQL database. Then why is there a word SQL in here? And it only implies the query language. That's it. All right, this one defaults to it. Now, this is also something that every blade that has a region on it or location is going to have a different default. Sometimes they're alphabetical. I don't know how some of them are listed. Maybe it's based on whatever someone picked before. And they're also called location in the older blades and region in updated blades. Location and region are exactly the same. It's just a synonym, and they're gradually changing all these blades and the UIs to match. So I'm going to put this one back into East US, and then the capacity mode. Now, the more you see when something is has a serverless feature, means that it will expand to whatever's needed, which in some ways could be really nice when you're first starting out. But if for some reason there's a runaway process and you're being bombarded with you're not supporting legitimate requests, you could be paying far more than you expect. So even though serverless is very easy to scale, it's also very easy to pay more than you expect. Provision throughput means I'm going to set a limit. I'm only going to support up to a certain speed, and that's it. That could be a bottleneck because it doesn't automatically scale beyond it, but it also helps you control the cost. So you need to figure out in each of these services, when that pops up, if it says serverless, it usually means limitless, and that means no limit on the cost either. And then notice here it says apply the free tier. Well, it depends on what your subscription is. I'm already in an account with a credit, so I don't really care. But I'll go ahead and say, well, no need to apply or take advantage of whatever. It doesn't matter. It's not going to cost me anything either way. Now, I'm not going to turn on global distribution yet. I'll show you that for later. I just want to get this database up and running with the core API. So review, create. Take about 13 minutes, as it's noted up there at the top, to create this database. Now I'm going to go create another one at the same time, a different API. So create another CosmosDB account. Choose the same resource group, but this time I'm going to call this one JTK Cosmos Table. And I'm going to switch to the table API, put it back in East US, provision, apply, etc. Now, to point out something here, remember in the storage account, we had table storage. This is the same structure, exactly the same structure, and you can use the same SDK in your code to work with either one. The big advantage here, though, is this table can be replicated as many times as you want around the world, and every piece of data in it is indexed. So it can be much faster throughput as well as more available to around the world. So you need to decide, if you need tables, is a storage account good enough, or do I need to use the storage API in CosmosDB for much broader availability and faster throughput and higher cost? All right, review and create. That's a second account because I'm using a second API. Let that start, and let's create another one. So I'm going to go back in again, create another CosmosDB account. And now I'm going to switch to another API, which I'm going to use Gremlin. Same resource group, different account name. Let's call this Graph. And this will be using the Gremlin Graph API. Put it back in the East US. Review. And create. So I've created 3 separate CosmosDB accounts because I want to use 3 different APIs. This will give me 3 different ways of managing my data. The core lets me manage JSON documents. The table lets me manage entities based on keys and values. And Graph will let me connect data points to what are called vertices and edges. All of them I can replicate differently from each other. One API I might want only in the United States, another API for Europe and South Africa, another API for Australia and Japan, or mix them all up in any way that I want. One could be replicated 3 times, another one 5, another one not replicated at all. So this is creating, whoops, I got a failure. Well, why was that? Oh, I'm using the free tier. That's why I really hate that they do that. Let's see, I can redeploy, but I have to go through a different interface. Let's see. Custom template, blah, blah. Right, sorry, what is it? Oh, resource group. And I don't think this one lets me take advantage of the free one, so let's see if that works. Yeah, because it defaults to one of the free options, they only give you one free, so it still failed. Oh, still stuck on free. Okay, let me see what I've got available. It could have been the others failed as well. Okay, I do have core, I do have table. Let me go through that rather quickly and make sure I turn off the free option. So I'm gonna put it back into demo RG. It's gonna be called JTK Cosmos, what was it, Graph that I called it? Yeah, Graph. I choose Gremlin Graph, East US, provision, blah, blah, blah. Oh, that was a different. Next, networking. Looks like it's not asking me this time. It may have been just the timing of it. Graph, Gremlin, provision, create. See if that goes through. All right, so now while we're waiting on this, let's go back and look at what you can do with these CosmosDB accounts. So we'll start with core. If I go in through core, it's a interface to a database based on the original core functionality, which was to host JSON documents. Notice it looks similar when we first start off. It says add a container, just like we saw within a storage account. But when we add a container, we're actually creating the idea or the concept of creating a database with a container. And the concept of a container here could be equated to, say, a table in a database. But before we can create a container, we got to have a database. So I'm going to create a database called HR for human resources. I'm going to create a container called employee because I want to keep track of all my employees. And I'm going to create a partition called department. Now, what this means is I will have a Cosmos database called HR. Within it will be an employee container ID. Same concept as a table. But notice this is different from this point down. You have a partition. Now, a partition is how the data will be logically grouped and separated by groups. So if I pick a piece of data that I know that maybe several employees could have the same department, be in the same department, then it can logically group those people together. The reason partition is important is it controls where they're physically stored in the background. And you do not want to choose a partition that doesn't have very many values. For example, a Boolean value, true or false, is the worst partition you could possibly pick. Also, you got to be careful of dates. A date could be very active one day, but not another. So you're creating what's called a hot partition where all the activity is in one place. So you want to choose a value that can evenly distribute the load for storage as well as computing power within that particular partition. Because a partition can be assigned to its separate VMs, especially if it's a very large database. So because employees usually are related to a department, and you could have a few people in the same department, or maybe even a lot of people, I might want to logically keep them grouped together like that. CosmosDB does not require a unique key because it depends on what's called a row key for its identity. This is if you do want to identify some piece of data, maybe like an employee ID or a social security number that you want to enforce uniqueness on. But don't confuse it with what we usually think of as the primary key. It's really just part of a key. The partition and your row key actually define the primary key of how you look it up. Another thing too, we see the use of RUs. That's basically the speed and what you're willing to pay for. This is saying that if I use 4,000, then I'm willing to pay about $35 or up to $350 a month. I can knock it down to 400. I believe that's the lowest you can go, which would be $3.50 up to $35 a month. So for development, demo purposes, that's good enough. So I'm going to say, okay, let's create one. Oh, they changed it. Yeah, 400 used to be there. Now they're saying you have to scale. Well, it says from 400. Must be database throughput capacity. All right, I'll just let it go at this. I'm going to blow them away in a minute anyway. The UI changes frequently, so you never can be absolutely confident that what you're seeing is what you saw last week or the month before. So you have to get used to that. These are not fixed user interface. I want to avoid the word stable because they work, but they're constantly being adjusted. So you do need to be able to adapt quickly to UI changes and just accept it and move on. All right, so it created a database called HR. It has a container in it called employees, but it has no items in it. These are the actual pieces of data, rows or records, however you want to view them. But in this particular API, they're called items. So I can create a new item. It will bring up a JSON editor. I have to work with the syntax of JSON to make this work. So I'm going to create an ID, and I'll just use employee IDs here. Then I may have a last name. Whoops. And then I put the last name in quotes. In that with a comma if I have more data. First name. And I'm following a general syntax that you would normally do with JSON, but you'll see that this is very specific in how this syntax has to be written. And then remember, I got to have that department in there. So I'll put a department, colon, and then I'll put them, say, in marketing. You want to be careful about your case because it will store it that way. And that may be all I know. So there's no schema. There's nothing that forces you to name anything a certain way or to be consistent. Nothing in this API enforces consistency, schemas, keys, so it's wide open. So this is not how you would normally, create items, but this is showing you how you could do it through the portal, and it does store it in the database. It's far more likely that you would create these documents within code, whether it was a web page with JavaScript or any other language that can write out a JSON document and store it in the database. Now notice the reason it has SQL as part of its name is it uses a select statement here. So select asterisk from C is saying show me all the fields, and C being an alias for container just says show me everything in here. So that's why as soon as you add it, it also reselects it so you can see what you did. And it also is showing you based on the row ID that you assign and the department. Now the actual row ID though is RID. That's how it's making sure that that's unique. But you can control the ID you want to refer to it as, and that would be unique within the partition. So in marketing, there's an ID of 1, 2, 3, 4. Now I can add a new item, and maybe this time, you know, I've got a completely different ID. It doesn't even have to be numeric. And then maybe I only know, say, their email address. I don't know anything else. So I could put, you know, someone at gmail.com, but that's usually not practical. So let's put at least their name. And notice that there's no requirement that I use the same spelling that I did before with last name. So I'll put in their last name as someone, and that's it. Nothing requires any specific field. In fact, I could leave out department and it would still work because it would just create an empty department value and still put it in the partition. But I should be consistent with that since I said that's how I'm going to use set up partitioning. So I'm going to put this person in HR. Now I've got a syntax here because I need a comma, and then I save it. So now I have two items inside this CosmosDB database using the core API. Now let's go down to another example. And I'm going to try to repeat the same scenario so you can see what's similar and what's different. In the overview of my Cosmos table, instead of a container, I add a table, which makes sense, different terminology. But behind the scenes, it's the same concept. I'm going to create a table in a database. So I'm going to do the same thing here to show you how I could keep up with some of the same data, just a different API. I'm going to call this table an employee. Click OK. Yep, come on. And then we'll have, now I created a table because I didn't give it a name. It automatically named it tables DB. I go into employee, instead of the word item, now it calls them entities. And I can add an entity and notice that it's a very different UI, but it's generally the same concept. Like, what are you going to use as the partition key? I can't really rename that, but I can definitely, you know, I can put the same information here. I'm going to use department values as the partition. The row key, I'm going to use their employee ID, and then notice how I can add properties, last name, stream, Turner, add another property, first name, and I'm trying to keep the same data here. And notice there's a slight difference here because we're not using JSON. I can actually pick the type. So let's say date hired. I can change this to a date time, and then I can choose the date. We hired him today. Put him in at 5:30 p.m. And then I can add this entity. Now that's still not SQL based. It is still not a schema, but you got one more, you've got an added advantage here though, is that you can control the data type. But there's still no enforced columns, there's no schema, there's no foreign keys. You're just collecting data based on keys and values. And if I add another one, there's no requirement that I even give them a name or a date hired. I just load whatever data I have. This is NoSQL. So this is the reason why you may find an advantage, and this is extremely fast because it's not supporting a relational concept. So in order for you to guarantee you don't have junk in here really, is the responsibility now falls on your application. Whatever applications are writing and storing data here have to enforce some type of schema within the app, not the storage. The data storage cannot enforce any type of structure or schema. It can be whatever an application puts in it, which does allow for a tremendous amount of flexibility, especially when data is coming in from devices, applications in multiple formats. You can decide when it's okay for data to be missing or completely different data coming in, and how you might want to collect that without confusing it with other data. So a relational database enforces a schema because it also needs to enforce data integrity. Not true with CosmosDB. It is not relational, does not enforce schema. It has no data integrity rules built into it, but it's extremely fast, and it can be replicated around the world. So that's the last thing I want to show you here. Go back to Cosmos Core, the original one, drop down into replicate globally, and it will present a map telling me where is the first copy of the data, and now I want to put something in Norway. It adds Norway to my list as a read-only copy, but I can say, no, I really also want to be able to write. So I want to be able to write in both the East US and the East Norway data center copies. And maybe while I'm at it, I want to send this down to Melbourne, set Australia Southeast, and then save it. That will now create the same database in Norway and Australia and start copying the data and synchronizing the data, and I can write to any of the 3 copies, and it will be synchronized to the other 2. That is something you cannot do with a storage account, but you can with CosmosDB. Notice it's also telling me at the top, just as a warning, when you add a region, you will be billed for the additional RUs and the storage, so it's going to triple my cost because it's copying exactly what I said do. So I just saved it. But that did not replicate my other API. So if I go back over here to Cosmos Table API, go into replicate, I'll say, well, I only want to replicate this to South Central US in Texas. All right. I also want that to be writable in both locations, and I save that. So each API has completely different interaction and also different locations if necessary. And then once this is saved, it has one more thing that you can set, and that is how quickly do you want it to synchronize to be consistent. All right, let's see if, did I get an error on that? Or it's just a warning, okay. Make sure it's saved. Sometimes if you leave this page too quickly, it does not save the replication settings. All right, I think that may have taken it. Let's go back to Cosmos Core. It's still updating, so it is take the direction I gave it, but still updating. And let's go here as well. And that one's also updating. So it's taking time to go create those databases and to push all that data to the other location. Now, once it's complete with that, notice that next option is called default consistency. There are 5 levels that I can pick to see how fast I want it to be updated. Immediately or eventually can also impact the speed at which you can update the data. Okay, so we've looked at 3 different types of stores: blobs, relational, and non-relational databases. This is the groundwork for you to decide which one of these are going to be the most appropriate to keep track of the data that I need to process, that I need to transform, that I need to make available for reporting. And how do I do that? Well, that's our next topic. Data factory. The data factory is an assembly line. It uses the word pipeline that sets up a series of steps or processes to move data or change the data. It is a data orchestration tool that lets you perform ETL or ELT transformation of data. So ETL stands for extract, transform, and load. ELT usually is a better approach for massive amounts of data because I need to extract and load it somewhere very quickly and then transform it later, or at leisure, you could say. It takes longer to do the transformation, so I don't want to delay loading it if I can transform it later. So it's just a series of steps. So that's very typical in a data factory pipeline. I pull the data from somewhere, I may change it, and then I load it somewhere else. This connects to a huge number of different data platforms: relational, flat, CosmosDB, all of them. It also allows you to not just transform the data, but to fix or enrich the data, missing values, different units of measure, whatever it is that you need to fix and streamline the data to make it accurate in the destination, you can do that. Now, this data factory originally is the same functionality that's in SSIS, SQL Server Integration Services. And what's really beautiful about this is that you don't have to leave SSIS. You can run SSIS packages from Azure Data Factory, even on premises. So there's no need for you to throw away all the SSIS packages that you've developed over the last 10 or 20 years. They can be used through the Azure Data Factory. That is a great feature so that you don't have to immediately change everything to the data factory. You can gradually start using cloud services to transform your data. Now, the terminology used in the data factory uses this concept. It's a pretty simple terminology. You have a pipeline of activities. Each activity can work on multiple data sets. In fact, it usually reads one data set in, does something to it, and writes another one out. So you've got in and out of every activity. An activity also may just be a logical application. It may not work directly with the data sets, but these data sets are available to you throughout the pipeline so you can act on them, enhance them, enrich, transform, etc. Now, these data sets also can come from, or usually start off from, external linked services. So a linked service could be a data lake. It could be a CosmosDB. It could be SQL Databases. It could be streaming data coming from an IoT device. So every activity may be linked to any number of services, but usually at least one if you're working with a data set. And then the data sets are the different stages of the state of a block of data. And you can handle multiple data sets at the same time, but you don't want to overcomplicate the pipeline. So the pipeline is a concept like you have in a factory with an assembly line. It's a series of steps and activities. Now, it's not just linear too. You can create branches and create parallel processing, simultaneous activities going on at the same time as another activity, in order to get the data from one place to another, to transform it in one state to another. All right, so that's one service. Let's look at another one. Databricks. Databricks is not a Microsoft product, but Microsoft is hosting it for you in Azure as a managed platform as a service. If you want to know how Databricks really works, go to databricks.com. Now, Databricks has some common functionality that the Data Factory does. The Data Factory is a Microsoft product. Databricks is not, but it has some similar functionality. Databricks is built on top of Apache Spark clusters, which is completely, of course, separated and developed outside of Microsoft. However, Microsoft is now hosting it, so you can leverage Databricks, which is a powerful system for not only transformation, but querying the data, applying machine learning techniques on it, a lot of different things that you might need to do from an analysis perspective, all of it within one product. You run notebooks. The default notebook is a Jupyter notebook, which includes the ability to run multiple commands within the same notebook. and each command can be a different language. So a Databricks Spark notebook can support R, SQL, Python, Scala, and Java in any combination. So you choose the command of any one of those languages at any time, even within the same notebook, to accomplish whatever needs to be done within that notebook. A notebook runs on a cluster, and a cluster is one or more virtual machines that are running Linux and Apache behind the scenes. By running Databricks in Azure, there are several advantages. The last 2 points especially is that all of your security can be handled by Azure through Active Directory. You know, who's doing what with the data, how are you accessing that data, this data, all over Azure services. And it can be integrated with other Azure services throughout your tenant, but especially true, you can connect Power BI into whatever storage Databricks is using or directly into Databricks. An example of how you might use Databricks is shown in this diagram. The red logo here just off center to the right represents Databricks. But notice leading up to it, I can be collecting data from IoT devices, sensors out in the field or on the manufacturing floor, logs, media, files, all of them streaming in either through one of my hubs, and we'll discuss these in just a moment, event hubs, IoT hubs, Kafka, which is also Apache-based hub. So those are 3 ways of collecting data real time, and this is an ingestion point. Same thing with the data factory. The data factory could also be extracting data from a source and pulling that data in and storing it into a data lake. So can the event hubs. So you start to see now, it can be rather difficult to determine what's the right service then. It depends on your requirements. Live data is usually going to come in through your hubs or Kafka. Any static data or data that needs to be collected, say in the background and it's not necessarily live, could be used, use data factory for that. All of it could be dropped in the same place, in a data lake, and then Databricks can read the data from the data lake, applying different commands to the data, and it uses what's called data frames that are distributed across the cluster in order to act on the data. ML flow that's mentioned also in this diagram stands for machine learning, and you could be processing data over a period of time. It could be real-time data and historical data. And then notice later on what you do downstream could be leveraged by a container in Kubernetes, which we haven't discussed, or it could be stored into CosmosDB, SQL, Synapse Data Warehouse, or reported live through Power BI. So Databricks can act as a very powerful core to your overall solution. And because of that, Microsoft is now implementing Databricks directly within Synapse Analytics. So you may not have to deal with Databricks directly anymore as you move to Synapse Analytics. And that's why I'm throwing these out initially, is because when we get to Synapse Analytics, you're going to see all this functionality rolled up into one product. So again, Databricks is not a Microsoft product, and it's a powerful product, but you would need to probably investigate it outside of Azure to see what the specifics are. Now these slides have been prepared for you, and particularly for these links, to go out and find some examples of what you can do. But I'm going to go ahead and create an instance of Databricks and a cluster and just show you how it's set up so you can get an idea. So just like we've done with the others, I'm going to go into all services. I'm going to type Databricks here at the top. Oops, maybe just Databricks. Odd. Oh, I'm under storage. That's why. Yeah, there it is. Azure Databricks. I have no instance of Databricks, so I'm going to create an instance of the service. We'll have similar questions, of course. I'll put it in the same resource group. I'll call this JTK DB for Databricks WS. See if that's okay. Okay, that's good. Put this in East US. And then notice the pricing tier. The standard or minimum is that you're going to run Apache Spark and you're going to secure it with Azure AD, which is good. But if you're also wanting to allow access through roles, then you need to move up to premium. And that's usually the typical way of doing it, because you want to control access to it and from it through RBAC, which are roles inside of Azure. So in this case, I almost always use premium unless I know that I'm not using roles at all. All right, networking, basically, how are you going to allow this to be used by networks or other services? Not changing that, not enforcing encryption. And so I'm just going to review and create. So taking the defaults and creating this Databricks environment. So this is now creating the workspace that I can create a cluster within, which will allow me to provision multiple machines running Apache, and then giving it commands through notebooks to read the data from any source, act on it, and then maybe write it somewhere else. So Databricks does ETL in a different way, but the same concept that Data Factory works. They're not exactly competing directly with each other, because remember, Data Factory is more of a series of steps or activities. Databricks is, you could say it's really just a collection of commands that act on the data. They can work together. In fact, you could call Databricks from Data Factory. Maybe you've done several steps that prepare the data, and then you invoke Databricks to act on the data, and then maybe the Data Factory picks up after that and continues on. I like to think of Data Factory more as a railroad track, you know, and what you put on the track is completely up to you. And one of those engines that you can make available to Data Factory is this, and that would be Databricks. And it can perform specialized functionality on that data. If I'm doing simple copy and simple transformation, then I would just continue to use Data Factory. But if I want to also introduce machine learning and some more sophisticated commands such as R and Scala, or anything else that's specific to Apache Spark, then I would get Databricks to act on the data. All right, this will take a while, but once it's up and running, I'll create a cluster and we'll create a notebook. Okay, let's see. And we will come back. And here's a link to an excellent tutorial that's available from Microsoft, is how to use Databricks as ELT and load data into a SQL data warehouse. It takes a little bit longer, of course, than what we have today in this webinar, but definitely want to get you to follow up on that. I'm going to loop back on this and create a cluster and show you how to set up a notebook. But other than that, be left up to you to take it even further. We're really just trying to cover the concepts of these services so you can see where they fit and what you may or may not use in your environment. Well, what's next? Well, the big one, the big service that is trying to bring all of this together, is called Azure Synapse Analytics. So it can also take a little bit of time to set up. So let me go out and start it as well as a separate service, and then we'll discuss what's similar and unique about this service. Oh, it actually finished. Okay, let's see. I'll go to my Databricks. Now, in the Azure portal, when you start Databricks, it basically gives you this launching site. This is not how you work with Databricks. Notice in the middle, the red logo, and actually this is a new logo. If you see solid red bricks, it usually indicates an older version, but this stylized red line drawing of stacked bricks is the new logo. And if we launch this workspace, it's going to take us to a completely different interface. So log in with the same account. Don't have to type your password again. It should just take you over. And this is Microsoft's interface specifically for Databricks. Databricks. Synapse Analytics has the same concept. So here I am in Databricks. I really don't have any machines running yet. So notice right here in the common task, you more likely than not from here on out, after your cluster is built, you're going to create a lot of notebooks. But the third option, you can create a cluster. You can also use the menu here on the left and create a cluster from here, create cluster button. A cluster is going to be a certain number of machines that you're going to pay for. So if you've got 5 running, 10 running, you're paying for every one of them. So I'm going to call this demo cluster. What mode is it that you want it? Notice this question mark. It's either high concurrency, standard, or single. So standard is pretty typical, but high concurrency is going to be, of course, the one that you might want to use. Notice though that it's clear. It says it does not support Scala if you use high concurrency, but standard can run any of them. So it defaults to standard, which is good for the demonstration. If you want to put it in a pool, these are just ready instances that are on standby that can more quickly handle a startup, so it doesn't have to scale out. So basically, it's like a minimum number that you want running. And then notice the runtime for this is a certain version of Scala and Spark. And if you click the drop down, it'll show you that there are different ones depending on whether you want to use the latest version, you want to introduce machine learning, and 17 more. So notice a lot of these are the same version of Scala and Spark. So the default is okay. You also want to enable auto scaling. And if you're not using it, how long do you want to wait until it's going to shut down? So I'm going to change this to 30 minutes. And then it says, okay, what machines do you want available to you? How many do you want? And notice here, it's not giving you a price, which is unfortunate because you are being charged for the worker type, the driver type, and how many you've got running, and that would be min and max workers. So we could go to a much smaller version. These are general purpose. And let's see, yeah, that first one is okay, but I'm pretty sure HDD is cheaper. Yeah, anytime you see HDD, it's not going to be solid state. So it's not as fast as far as accessing data. I believe the first one, general purpose, is solid state as a default. Let's see if we got, yeah, and each one of these expand out more and more, a lot of choices. So you may have to look up this SKU separately to see what you're going to be charged, but I'm going to go ahead and take the defaults. This is going to say I want at least 2 machines running, and I want it to be able to scale up to 6. I'm going to drop this down, say to 4. And then the driver is the machine that's handling all the requests. It's going to distribute the load across the other workers. So it could be that it could be a least powerful machine or more powerful, but this is saying, I'll just keep it the same. And that's your initial setup of a cluster of machines that are going to host your data usually in a round robin fashion. Every machine is going to hold a piece of your data, and you can access that through what's called a data frame. So I'm going to go ahead and create this cluster. It can take a while. And while that is being created, I can go ahead and get started on my notebooks. So let me let that go a little bit further. Usually if you move off of this too quick, it may not get the initial startup. And again, if I go home, well, actually, let's go to clusters. Yeah, here we go. So it doesn't think there's any clusters here yet, but if I refresh it, it should come up with one that's pending. That's one that's being, yeah, there we go. So demo cluster is pending. Now my workspaces are going to allow me to create a notebook. So if I create a notebook, let's call it demo notebook, one of the first things you can decide is what's going to be the default language for this notebook. And even if you choose one of these, you can change languages inside the same notebook whenever you need to switch to another language. But if you know you're going to write primarily in Python, then set that as a default. If you're going to write primarily in Scala, set that. And then notice what cluster or what machines, plural, this notebook will be associated with. You can create multiple clusters, each with different types of machines, sending specific notebooks to those machines. So even while the cluster is being built, I can start writing commands. Now, this means that I have to know Scala, that's up here at the top, to get started. Or I can change the language here, and I can create as many command blocks as I want. Each one of them can switch between different languages. I can run them individually, or I can run all of them. So this is where I'll stop, because you'll have to understand the syntax of any one of these languages and what the data is that you're working with in those data frames. And we don't have anything yet. This is just to let you see the setup of how to get to this point. And this is now really called a Databricks workspace. And the reason why is we also have Databricks or Apache Spark in Synapse Analytics. So you're going to see this again. So if we go back to clusters, it's still spinning those up. So even if I did have a notebook, I couldn't run it until that cluster was available to host whatever commands I type in here. Now, you have plenty of notebooks that you can pull in. You can import notebooks from many different sources, including Databricks itself, GitHub. So instead of writing any of these from scratch, there are plenty of commands that are available online. Okay, so that is setting up Databricks. What else? We have Synapse Analytics. Synapse Analytics is bringing all of these technologies together into one interface. So if you see here Synapse Pipelines, and notice the logo, that's the same logo as Data Factory. So Data Factory pipelines are incorporated into Synapse Analytics as simply pipelines. We can work with SQL databases. Within the Synapse Analytics, we have what's called SQL pools. SQL pools are SQL databases. They work with the same T-SQL syntax. However, you really need to change the schema in a SQL database intended for a data warehouse by using what's referred to as the star schema of facts and dimensions. If that's a new concept to you, please be sure to look that up. You do not want to just port over OLTP data tables without changing them, and you need to redesign your data warehouse so that you're focusing on the star schema or snowflake schema, where the facts are all consolidated in one place and your dimensions are how you want to aggregate and report on the data. Completely different format, but fortunately, you can still continue to use T-SQL. Synapse Link allows you to link out to other data stores like CosmosDB. In fact, that's the logo for CosmosDB. Synapse Studio is very similar to what we just saw with Databricks Workspace. So you have a completely separate user interface that lets you access all of these tools in one place. And then in addition to SQL, we also have support for Spark, which is synonymous with Databricks. Synapse Spark is allowing you to work with R and Scala and Python and work with the same data that you may be working with under your SQL data warehouse or Synapse Link. So this is helping consolidate everything into one place. So this Spark pool is making Databricks available to you in this interface. Synapse SQL is making a SQL database available to you at a very high level, massive parallel processing. So you could have 60 VMs running in the background, all supporting your SQL database for extremely fast queries and processing. And it comes at a high price, but you don't always have to keep it running. So if you want massive parallel processing of relational data, you can't beat Synapse SQL in Azure. That's the top of the line. So I think this is a great change in just this year. This has been made available, and in one place we can answer some of your most typical questions about your data, and that is these different analytical types. Synapse Analytics, first of all, offers both serverless, which means limitless in scalability, or dedicated resources that you define as SQL pools. So do you want only just 3 nodes in your cluster, your pool? Do you only want to, limit the processing power? Then you would use dedicated resources. If you want it to scale as needed, as well as scale back when not needed, you can choose serverless. Synapse SQL is a distributed query system. What that means is your data is not all in one place. It's distributed across a cluster of machines, but you still use T-SQL no matter what. If you use Apache Spark pools in addition to SQL pools, you can then also use Scala, Python, Spark SQL, and C#, which is a new addition beyond just what Databricks supports. So Microsoft made sure that there was support for C# within Synapse Analytics. And those questions you can answer fall under 4 categories: descriptive, diagnostic, predictive, and prescriptive. Descriptive is what happened, or even what is happening. So descriptive analytics lets you see what's happening now and into the past. All the data that you've collected, we can find out exactly what happened. Typical reporting. But diagnostic, you can start seeing, well, why did that happen? You can see correlations between data and find out why did that happen and still happening. Predictive is what is likely to happen in the future based on the past. So you can do analysis on what has happened, say, in the last 3 years to predict what could happen in the next 1 year, such as creating a budget. That's a typical predictive analytic job, is to create a budget for the upcoming fiscal year. But then we have prescriptive. Now, prescriptive combines real-time data with predictive to find out what is happening right now compared to what has happened and likely to happen, to find out how could we respond to this? What should we do about this? So, such as discovering anomalies, fraud, unusual changes immediately in real-time data. These are all the goals of Synapse Analytics. And that's typically the goal, of course, of setting up a data warehouse. So Synapse Analytics includes the warehouse directly within the service and includes these tools that allow you to analyze the data depending on which languages you're comfortable with and which ones. Now, some of the languages will provide certain types of analysis that others do not. So it's not really a matter of choosing what your favorite or what you're comfortable with. It's more about knowing which one you should use. This is where Microsoft's going with everything. It's very clear as of this year, with all these products that they've had out there separately for so long, they're consolidating them into one place. So if we look at the concept of pipelines, exactly the same thing we talked about with the data factory. Staying within Synapse Analytics, you can set up a pipeline to ingest the data, prepare it, and then notice too with Synapse Analytics, whether you're using SQL pools or Spark or even linking out to other stores, you can model it and make it available and serve it up. And of course, the premier tool from Microsoft that's always considered your first visualization tool to go to is going to be Power BI. Power BI can connect to any one of the stores, including the data lake at the bottom of this diagram. So whether you have logs, media, files coming in as unstructured data, usually dumping that within a data lake, the data lake can be used as a holding area until we process it. So we have Synapse SQL, Synapse Spark, and Synapse pipelines themselves. Or we could go outside of Synapse and leverage Data Factory by itself, Databricks with or without the Data Factory, or Databricks by itself. You're probably going to see less and less direct use of Data Factory and Databricks in favor of just doing everything in one place. I mean, that would definitely be my preference. Instead of having to jump between different tools, why not just stay within the Synapse workspace? So let's do it. Let's set up Synapse Analytics, and this will be very similar to how we set up Databricks. So we're going to create a Synapse workspace, and we're going to go ahead and give it a data lake account to work with. All right, so we already have, of course, our Databricks, so this will be separate. Let's see, do I even have it in my favorites? For some reason, I don't see it, but let's see. Oh, there it is, right here at the top. Azure, no, it's not. Let me check the star. That'll put it in my list down here, and then I'll move it. Let's just move it all the way up here. Yeah, that's close enough. I'll see that right off. So if I go into Azure Synapse Analytics, now keep in mind too that if you come across any old documentation, this was originally called SQL Data Warehouse, but it's much more than that. It still has a SQL Data Warehouse in it, but now you've got all these other tools. So we're going to create a workspace, which is synonymous to a Databricks workspace. So Microsoft is basically redesigning Databricks within Azure. They're not eliminating it. It's still, you can have Databricks by itself, but they're going to incorporate it as part of a larger product. So we're going to put it in the same resource group. And notice here's an interesting thing you may see on other blades. In addition to a resource group, they're also going to say, well, would you like to also name the managed resource group that Microsoft is going to create for you when it needs it? Which is a bit odd, but it's saying we're going to keep what we create automatically for you separate so that you don't have to worry about managing that in your own resource group. So I'm going to name it, and I'm going to just put M in front of it. So MRG for managed resource group, or you could think of it as Microsoft, you know, the M for Microsoft, but I'm letting Microsoft manage whatever they need in that group. I'm not going to manage it directly. And now what do we want to call it? Well, I can call it JTK Synapse. Wait a second to see if that's available. Yep. East US. And then notice here, it says, okay, you need a data lake. So here's where you can see it's mandatory that either you create a data lake from this interface or you select one you already have. And I do. I created one earlier. And within it, this is another reason, I already created a file system. So that's the first container in the data lake called DataFS. And then notice too, it's going to handle your security for you. If you're going to need this for Synapse, then you have to be a contributor to that data lake. So it says, okay, go ahead and set up the permission for me to be able to do this. Otherwise, I'm going to have a problem. I'm not going to be able to read that data. So instead of me having to manually set this up, this says, okay, before we create a workspace, here's the data lake, here's where you're going to work, making things much easier to set up this whole environment. Next is security. How are you going to log in? And notice this is assumed SQL admin user. The password, let's see, I'll make it PA55W.RD1234. Good. And PA55W.RD1234. Good. Now, just to show you what that is, it does have to be 12 characters. So I used the same password I gave you earlier and just added 1234 on the end. Other options such as encryption, allow pipelines to access SQL pools. Absolutely, you want to do that. And then do you also want to allow network access to your data lake? I can handle that separately, so no need to worry about that. Networking, allow connections from all IP addresses. right now, that's fine. Or if I uncheck it, I'll have to make sure I control how it's being able to connect. But I'll leave that checked. No need to enable a virtual network. I can do that later as well. Tags, nope. Review and create. Let it validate it and then create. Now, this does not create the cluster yet. It does not create a SQL pool yet. I can do that after the workspace is in place, just like we did with Databricks. And then I can decide if I want either or both. So instead of having to define them externally, I can now do it as part of this process and say, yes, I do want a SQL pool. I need about 5 or 6 machines running SQL. I also need Spark because I want to run notebooks against another cluster of machines to work with the data. So I have both major tools available to me within the same studio immediately. Okay, I'm just pausing to keep looking at questions if you have any. So don't see any new ones now. So we're letting this continue, and we'll be creating a Azure Synapse Analytics workspace that we're then going to go into and set up a SQL pool. I'm going to point out too how you create databases in that SQL pool. Then we're also going to set up an Apache Spark pool, which basically is Databricks. And then we're going to open up the Synapse Studio to work with both. All right, that's taking a little long. In fact, this actually can take 5 or 10 minutes. But let me show you, we'll just minimize this for a second. Here's what we're going to be doing as it comes up. We're only at the first step, create a Synapse workspace with an existing data lake that we had. We're going to create a SQL pool. And remember, that is going to be a cluster of machines or a pool of machines that are going to be hosting a SQL database for me. So we don't have to create individual databases. And it's not that these are SQL databases. These are acting as a single massive parallel processing platform of up to 60 machines, all hosting your SQL data distributed across multiple machines so that we can read and write the data in parallel for extremely fast processing, almost immediate response on your data coming out because it's leveraging the memory of all those machines as well. So whether you physically write the data to the SQL pool or read the data and work with it, they've optimized not only the reading and writing capabilities because it's massive parallel processing, but also leveraging all the memory of those machines to act together as a one virtual, well, it's not a good word, a one logical SQL database. So you don't pick the nodes you query, you simply query the whole pool and it will go find the data from multiple machines. Apache Spark pool is yet another cluster. Remember, that's the one that distributes Apache across multiple machines in order to process the data using the different languages that are supported by Spark Core. This is interactive through Synapse Studio. So once we set up either one of the pools or both of them, then we can go into the Synapse Studio and interact with both of them. So we can set up, create tables in a SQL pool, and those tables can be distributed across multiple machines. And we're just going to create a default, very simple one, not going to give much thought, of course, to the structure. And then we're going to see too, how can you take advantage of serverless databases, which means outside the pool, it's going to scale to whatever's needed. So serverless databases are a newer concept in both SQL databases as well as here, so that you don't have to provision or dedicate exactly what you want. But at the same time, it is serverless, which means limitless and may go to a very high level, incurring additional charges. Now, also within the studio, we have multiple references to the concept of hub, which I think is unfortunate. It's nothing to do with other hubs. It's more of a menu item. So you go to the develop hub or develop menu, we'll create a notebook, just like we did in Databricks. It will be a Jupyter notebook, and you can import and export your notebooks under the Develop Hub. We can also use the Integrate Hub, which borrows a word that we originally saw in SSIS, integration services. So the Integration Hub or Integrate Hub is bringing Data Factory into this studio. So you create a pipeline, and it'll show you how you can do a simple copy activity. That's just the setup. There's so much more you can do and get started with. So I have that link at the last bullet point to go out to Synapse Analytics, get started, and start investigating how rich this environment is. Okay, so let's go back to, let's see if it's set up. Yes, good. So it is set up. All right, I'm inside the resource group. There is Synapse down here. And before I go into the studio, which is right here in the center of this blade, I want to set up my analytics pools. So there are none yet. If I go into SQL pools, it does have a built-in serverless support for databases. So I could start using this in the studio immediately, but it's not provisioned as a dedicated set of resources. This is the one that can grow automatically without any type of configuration. I will demonstrate that in just a moment, but let's go ahead and create a static predefined pool that is still quite high. It's still massive parallel processing, but I'm going to control what it can do. So let's call this JTK SQL pool. Notice that the DWs is another unit. We've looked at DTUs, RUs, and now DWUs stands for data warehouse units, or DWs, data warehouse units. So I can say, how much power do you want? So of course, the higher you go, the higher the cost. And notice down here, it's per hour. So 30,000 DWs is $453 per hour, more than some lawyers. So if I push this all the way back down, go as low as I can, I'm still paying $1.50 per hour, which is a big improvement, because in the past you really couldn't control that to a reasonable, affordable level when you first started out. Now this is okay, but that's going to at least cost you about $36 a day, which is about $1,000 a month. So this is something you don't want to just play with on your own account without monitoring very carefully. And even with your any type of trials or Azure Pass, MSDN, you can exhaust your credits very quickly if you're not watching this. So I've pushed it as low as it can go, and then go to the next one, which is additional settings. Use existing data. Now this is interesting. Notice that we can restore a backup of a SQL database into this SQL pool. Now, the way the data would be distributed, though, may have to be adjusted, but this is allowing you to do backups and restore into different instances, especially if you want to tear down the pool entirely. You could do a backup and then use this maybe once a quarter, since it can be relatively expensive. So I'm saying none, review and create. It's giving me a heads up that you're committing to $1.50 an hour. If I could go lower, I would, but I can't. And then we're going to create. So that's going to create a massive parallel pool of machines that will scale, but only up to that speed that I'm paying for. So that keeps it throttled. You don't get that with serverless. Serverless does not have a throttle. It will scale to whatever load you put on it. All right, so let's wait a few seconds here for this to get started. Okay, so it's in progress. So now if I go back to, actually they don't provide a, nope. Let's see if I can go, nope, can't go there either. Let's go down to, where's my Synapse at? There it is. I'll go back into this workspace, JTK Synapse. And this time I'm going to set up an Apache Spark pool. Basically, setting up exactly what Databricks did. So there's none. In fact, there is no serverless version of Apache Spark pools yet. They may come up with one. So I'm going to click New. It says, okay, what do you want to call it? Call it JTK Spark pool. What is the size? Keep it as small as possible for costs. I can also disable auto scaling, but I'm also going to push the nodes all the way down as low as I can. And notice this is slightly more expensive at $1.83 per hour. Next, additional settings. Automatic pausing, absolutely. After it's idle for 15 minutes, shut it down. And notice here, what are all the versions of what you're going to be using? I can't change some of these others, and you may be able to in the future, but right now, the only thing you can change is the version of Spark, which implies the other versions that it supports. So if I go back, say, oh, they don't even have it. So they're only supporting one version right now, but as they support more and more versions, it may indirectly, I'm sure it will indirectly affect the versions of the other products. And then I could pass it a text file that has configuration settings in it. So in addition to what you can do through the portal UI, you can pass additional configuration parameters. All right, no need to change any of that. Review and create. And there we go. So I've created one SQL pool. I'm creating one Spark pool. And then once those are created, then we should be able to leverage them within the Synapse Studio. Making sure that continues to set up. Good. Like I said too, if you move too quickly sometimes off the deployment, oh, there we go, that was fast. So go back in. I can go up to the workspace, take a quick look under SQL pools. We have one that's dedicated, one that's serverless. Under Apache Spark, we have the Spark pool. All right, so we have enough to work with now to move into the studio. So right here on the middle of the overview blade, we can open the Synapse Studio. And just like Databricks takes us to a whole nother interface, also Data Factory has its own separate interface. Same thing here with Synapse Analytics. You can launch the studio from the Azure portal. Oh, I did have some other questions. I'm sorry, I just expanded the questions out. I just now saw it. Says, please finish the Synapse demo, but can Synapse create extracts from the warehouse? I would like to know how our internal scheduler can be used to source that file and FTP it out. Also, if a SQL DB is created, can microservices be created to expose this data via API calls, or would it make sense to host those microservices in Azure Cloud Platform? Wow, there's a lot of implied questions there. Can Synapse create extracts from the warehouse? Yes, I'll answer that right off. Internal scheduler can be used to source that file and to, now, as far as FTP it out, that means you would have to send it to a store where FTP is supported and source that file and STF. Yes, it can do that, but not directly out of Synapse. Remember that with the pipeline, as well as some of these other tools, you're moving data, but you can move it to a location that you have designed to use FTP. And if the SQL database is created, can microservices be created to expose the data? Yes, microservices can be. And then the next question is, would it make sense to host those microservices in Azure Cloud? It would probably make better sense if they were in Azure Cloud, especially if they're based on Azure microservices that are supported either through Service Fabric or Kubernetes. yeah, it definitely makes sense, especially if the microservices are already running in the cloud. That would probably make the best sense, but they don't have to. You could access, the data through API calls. But again, keep in mind that the only storage in Synapse is the massive parallel processing of the SQL databases. Spark Pool is not a storage environment. It's basically setting up a cluster to run commands. But you can also use Synapse to move data. So you can move the data out to somewhere else and not pay for massive parallel processing at all times. If you are relying on MPP, massive parallel processing, for all storage, that is a very expensive proposition and should only be used if you need the data warehousing reporting capabilities, such as live data that needs to be presented, say in dashboards and very complex reportings at all times. The concept you have here of files that can be FTP'd out or making microservice calls to data, I would say needs to be moved to a different store, but then microservices, of course, could access those different stores. I hope that answered your question. There was quite a bit things implied. All right, so we're in the studio. Notice it's similar to what we saw within Databricks, but this is Microsoft's new studio to help, as you see across the top, ingest, explore, analyze, and visualize. And Power BI is now incorporated here to make it even easier, and work with some sample code and some quick starts to start seeing how this all works. Now, because we already set up a SQL pool and a Spark pool, we can use those directly within here. So over to the right, we're on the home page, but if you drop down, the next hub, as they refer to it here, is for data. So if we go into the data hub, we expand databases. Notice it's got that SQL pool that I created earlier. And remember though, this is not a database that resides on a single machine. This is a distributed database across a massive parallel processing platform. So it's going to be much faster than you've experienced even with SQL databases or any clustered SQL Server environment. So notice if I go into tables and try to expand tables, there's nothing here. So this is just the SQL structure that you become used to with SQL for both tables, views, setting up schemas, setting up stored procedures, but completely empty right now. So external tables and external resources become much more important in Synapse Analytics because I can point to a data lake. I can query a data lake through this workspace, through this database, without even moving the data. So data as it's coming in live, say over an event hub, I can have this query the data, pull the data in through what's called Polybase, and drop it right into tables that I can process as fact tables and dimensions. Now there's a plus sign up here at the top, and notice it's saying I can create other databases. I can connect to external data. I can go through all of these steps. I can also go to the tables folder that you see here, click the ellipsis, and I can create a new SQL script to create a new table. So in a very similar way that you've used SQL Server Management Studio over the years or Visual Studio, this is going to have similar interfaces to interact with this MPP database. Now this gives you a stubs out, the syntax for a single table. So of course you could change this to whatever you want. You know, we probably should stop and create a schema first, but we'll call this just demo table. Column 1 is an int. You know, I can call this ID if I want. I can create multiple columns, but here's a very important one that you need to be aware of, is how is the data distributed across the pool or cluster of nodes. So you have to use distribution. If you don't include distribution equals, it will default to what's called round robin. So every row gets put on any machine in a round robin fashion. with no consideration as to is this the most efficient way to do it. Round robin is not always, in fact, it's probably more often not the best way to distribute the data. And the other two options are going to be replicated or hash. When you use hash, you have to identify the column. In this case, I changed it to ID because I changed the name of the column to ID. It's going to create a hash value for the ID and set up and associate that to a machine somewhere in the pool as to where this data will be. So providing much faster access. You should always use hash distribution on large tables. When we talk about millions and millions of rows, hash is going to help you pinpoint which machine it's on much more quickly. If it's round robin, there is no record of where it is that you would end up having to query every machine to find it. The other one, called replicate, means the table is so small, there's no need to distribute it and spread it out across tables with just partial data. It means replicate. The entire table is copied entirely on every machine. So if you've got tables with only a few rows in it, very small dimensions within your data warehouse, then the ideal distribution would be replicate so that you don't communicate to other machines. So large tables should be hashed, very small tables should be replicated, and then round robin would be, round robin is the default, but rarely ever is round robin the most efficient way. If you just want to evenly distribute the data because you're going to read it all anyway, that would probably be a good reason to use round robin. You're reading all the data anyway. You just have all the machines read them simultaneously. All right, so let's see if this is syntactically correct. Oh, another thing too is the clustered column store. That's a SQL feature that is going to organize the data into a completely different structure than the original page structure of rows in a page. This is going to keep all the columns or all the data in one column in the pages together for easier aggregation, for easier drilling down through dimensions. All right, so let's run this. We got clustered columns. Oh, I don't select it. When you select it, it doesn't run the whole thing. I was highlighting it. Yeah, so now it worked. So now if I go under tables, well, let me refresh. Yeah, now we have a table called demo table. It has columns in it, just ID. And then I know that that value in the ID is going to distribute it across the machines. And it's kind of like a first level index. You go to your machine where the hash is being kept, and then you look it up in an index on that machine to find the actual ID. So it should be familiar to you how this works, in that you're basically just setting up a relational database. The big difference is, again, external tables. External tables are a wildly different thing because, notice here, I can point to any location, data source, and any format. This is where you set up links to your data lake. So I can query an external table through Synapse, or I can pull the data in and load it into an internal table. So the location could be a path to your data lake. The file format could be comma delimited. And so you've got these three values that basically are pointing out to a location somewhere else. Now, in order for that to work, though, you got to have the proper clearance. And so that's why we saw earlier, do you want SQL Synapse Analytics data warehouse to be able to point out to a data lake? So that's why it was included in the workspace up front. All right, now what else can we do? Well, if you go to the develop, the next one, we do have the scripts that we have been collecting. They're going to be made available to you. But once you've used them, you may not want to keep them around. And then we have a plus up here, and we can add a notebook. A notebook, as we've already seen in Databricks, notice how it coexists right here in the same place with our SQL scripts. And it gives me one line of command to start with. And then up here at the top, which cluster or Spark pool do you want this to run on? Same concept as Databricks. Here are the machines in this Spark pool that are going to run these commands. And since I said the language up here is Python, then I have to write Python code, or I can change it to Spark, Scala, C#, or Spark SQL. Slightly different than T-SQL, but still SQL. So whatever language you're comfortable with, or whatever is appropriate for the work you need to do, then you can add them into a notebook and save them. These are Jupyter notebooks. If you look over here to the right, they do have an extension of .ipynb, which doesn't spell Jupyter, but that is the format of for the file extension for Jupyter notebooks. Okay, the fourth one, pipeline. The same concept we saw within the data factory is here. They've got a slight UI problem. It didn't clear the screen, but if I go up here and click plus, I can add a pipeline. A pipeline, you can name it whatever you want. And then here is a list of all the activities that we can perform that are predefined, whether you want to introduce machine learning, you want to read from Hadoop. HD Insight is Microsoft's implementation of Hadoop. You want to, well, let's look under general. Come on, expand. So here are all the things you can do under general. These are just steps or activities that you can add to this designer, a graphical designer. Probably one of the most common, though, is to simply copy the data. So where you want to copy it from and where you want to copy it to. Then you could also introduce a data flow. You can also indicate that the copy data happens first, then the data flow. And then when let's see which one this is. Yeah, but then I can go in and look at the actual definition of it, and you'll notice still it's pretty common that this is JSON. So I can make some tweaks directly within the JSON of what this data flow is. The connecting of these activities can be based on the completion of the previous activity. So I only follow this connection. If it's green, that means only if the previous one succeeds do I follow this path. If it fails, I follow another path. If it doesn't matter whether it succeeded or failed, it just completed, then I follow this path or skip it. If you've ever worked with SSIS, this is a very familiar concept. The UI is different, but I have to go in and fill out the parameters for every one of these activities and define, how I'm going to, in this case, define a data flow. Down here at the bottom is where you're going to see more detail about the different areas that you can work with, how you're going to define it. It all depends, of course, on how complex the activity is as to what needs to be done. But all I'm doing is creating a series of steps. This designer right here is very similar to the data factory by itself. But notice it doesn't use the word data factory here at all. This is a pipeline in Synapse as opposed to a pipeline in data factory. I fully expect this, probably to replace data factory, but data factory still has its use externally. If you're not using all the features of Synapse, then you could just use data factory by itself. This is the latest and probably the primary area that you're going to work in as a data engineer with your data scientists and information workers, is to get this set up to make it easier for them to start using tools like Power BI or Tableau or other tools that they may need to access this data. And the pipeline is going to help you build the data, extract it, transform it, load it, and probably load it into your SQL data warehouse, your Synapse SQL pools. A lot of cool stuff here, a lot to learn too. So let's take a moment to look at streaming. Streaming means that you've got real-time data coming in. Think of an ICU unit at a hospital. A lot of devices are being used in rooms, that are monitoring, health signals coming from patients. We want to know exactly what's happening real time, especially if something goes wrong. Think of something less critical, maybe as well. It depends on your outlook, I guess. Sports scores, stock prices, traffic. Between real-time traffic for redirecting traffic. Anything that requires real-time analysis can be ingested through either event hubs or IoT hubs. Now, IoT hubs, IoT stands for Internet of Things, means that you've got devices that are capturing data live. It could be toll booths on a highway, for toll bridges. It could be anything that you may want to be able to interpret immediately. Probably a very common one would be financial transactions. If I have the means to detect fraud, credit card fraud, insurance fraud, whatever it is that you already have a mechanism that you could analyze something coming in and compare it to history in order to determine if it's fraudulent or an anomaly. This is a great place for streaming data. So there on the black side, those blue circles, those blue dots, just indicate anything that's generating constant data. It could be weather devices across the country measuring temperature, humidity. You could have millions of them, throughout the entire world, all of them sending data constantly, every few seconds, every minute, whatever it is you got them set up for, to a single event hub. An event hub is a ingestion point to capture data to the scale of millions of events per second coming from any number of devices. So the event hub has been designed to capture events, but not store them. That's another key point. An event hub does not store data. It simply creates a channel of delivering the data. An event hub can drop data immediately into your blob storage or your data lake. There's something called event hub capture. Event hub capture can say, as soon as this comes in, store it. Question is, can event hub source from an existing copy? Yes. In fact, that's how you can link it together. The event hub can be directly capturing the events, or it can be integrated with Kafka. So yes, they do work together. In fact, Kafka could feed event hub while other streaming data is also feeding the same event hub, just to centralize it. And then event hub could be told, we're just going to drop the data here. That's not ideal because if you're not acting on that storage immediately, why even have the event hub? It's probably more likely that you have other applications or other functions or something that's listening and subscribing to the event hub and responding immediately. The purpose of this diagram, though, is primarily for that third column, prep and train. Stream Analytics also has no storage, but it can connect to the stream of data coming out of the event hub. It can dip into that data. Just because the name stream, the logo even implies water. You're intercepting the stream of data, just like dipping into a river, and you're going to test that river as it's flowing by right now. Stream Analytics can capture not just samples of the data, but all the data for a certain period of time, but not hold on to it. So you could check all the data coming in through the event hub through what's called Stream Analytic jobs. The Stream Analytics job has the concept of a windowing sample. Let me sample the data every minute, every 5 minutes, every hour, everything within an hour. Stream Analytics relies on SQL. So you don't have to learn yet another language. You can use SQL against the stream of data coming through. So Stream Analytics can be attached to event hubs. It can be attached to IoT hubs, and it can also be attached to blob storage. Now, blob storage is considered a static source, so it's referred to possibly as near real time because it's reading the data in a sequential manner. It's not ever going to reread what it's already read. but it's going to read through the data that's in a certain location in blob storage. That's usually okay if you really don't want to connect, say, to just a single or multiple event hubs. You may want it to be indirectly stored, especially if you need to do something like a playback. I need to run that over that data again. The event hub cannot do that. The event hub is one way only, and you can set how long it should hold the data before it's read, but it's never a persistent storage. And then what does Stream Analytics do? Well, it can even transform the data. So not only is it doing sampling of the data, but it can also act as ETL on a very small scale as far as time, units of time, but it could still perform ETL on data that it's collecting. But its primary purpose is really to give you an update on live data. So how does it know, what something may be normal or abnormal? Well, it's not in this diagram, but we could compare it to a machine learning model and say, is this normal? Somebody just spent $300 at a fast food store restaurant. Is that normal? Well, if they're feeding a whole baseball team, I guess maybe so. But you have a history of maybe per person or per customer or whatever it is of what is normal behavior, and your Stream Analytics could compare that against a model and say, wait a minute, this is way out of norm. This is nothing like they usually do. So Stream Analytics can show up that abnormality. And then it can go ahead and whatever it's doing with this sample of data, it could throw it away or store it in another destination. CosmosDB, SQL Database, your Synapse Analytics, or simply make it available live through Power BI. Power BI can connect to Stream Analytics in real time and just show you the data as it's coming through. So, for example, if you were connected to Stream Analytics that's reading weather information, you could have a dynamic map that's showing you the weather as it is right this moment, the humidity, the temperature, wind, whatever it is, and present it without collecting the data. So if you don't need historical data, you could just simply rely on Stream Analytics. But remember, you could do both. You could have something else subscribe to Event Hubs, get exactly the same data, aggregate the data and store it in a data warehouse for historical purposes simultaneously. The Event Hub can be consumed by any number of subscribers, simultaneously the same data. So Stream Analytics can act as your real-time aggregate and reporting tool, while something else could be acting as historical collection and aggregating the data over a longer period of time. So up front, what type of hub do you need? Well, IoT hubs are a specialized type of hub. Remember, event hubs are one direction. They're collecting data associated with events and sending them in one direction, and that's it. Kind of like an actual river. The data is flowing in one direction. But when you move to IoT hubs, you now not only have a way to channel messages coming from devices, but you can manage those devices. So IoT hubs also incorporate ways of managing and provisioning devices. So we have what's called DPS, Device Provisioning Service, built in with IoT management as part of Azure. And we can stream the same number of events as an event hub, millions of events per second from millions of devices. So event hubs are not necessarily tied to any devices. They could be used for data coming from a device, but there's no way to talk back to the device. So the fourth point here, we have bidirectional support for communicating to and from those devices, which can be very helpful in maybe making adjustments to the device, reconfiguring it. What's also not mentioned here is we also have the concept of an edge device, especially useful when devices are not always connected to the internet. Maybe there's no Wi-Fi connection. An IoT edge device could be near IoT devices to act as a collector temporarily until there is a network connection to send the data to the hub. Or it could be used as a a local management point of multiple devices. So especially for mobile type devices that are not necessarily near any way of connecting to a network, you may have an edge device that could collect it in the meantime. So this can support not only millions of events per second, but millions of devices anywhere in the world that can connect and register with your IoT hub. It also supports multiple messaging patterns, simple request and response, or simply sending telemetry, like the example of collecting weather information, just capturing it every second, sending it in. And it also integrates with stream analytics, just like event hubs, so you can capture that data and perform analysis on real-time data as it's happening, comparing it to historical data or machine learning models. This is an explosive area within, of course, the internet, is having devices. Every one of us now probably have some type of IoT device internally. Every so often you can hear my Alexis machine go off. You may have thermostats, you may have other kitchen devices, refrigerators that are now communicating back to a central point somewhere, and you can create your own as well, registering those devices to your own applications, your own solutions. A very simple example, as you see here, is we have things out in the world, the Internet of Things. So whatever that device is, whatever it's doing, could be in a car, vehicle, appliances, whatever. We need to identify that thing, and that's exactly what DPS does. IoT Hub device provisioning registers, recognizes, and provisions, sets up a communication link into your IoT Hub, which acts as a gateway into whatever you need to do within the cloud. So they've just added some simple ones here, such as insights and actions. It could be stream analytics, it could be storage. Actions would be, how would you respond to a piece of information? What do you want to do with it? How do you want to store it, respond to it, whatever. So it's a simple concept, but when you start multiplying this by hundreds and then thousands and millions of devices, you need something to act as a collection point, and that's exactly what the IoT Hub does. And then allows you to push that data into your analysis solution. And then, of course, collecting that information ultimately, say, back in Synapse Analytics, your SQL pools. So stream analytics sits between what's producing the event and what's consuming the event. In this simple diagram, you'll see that stream analytics is the larger box in the middle. It has inputs and outputs. It can be connected to hubs shown on the far left, or that hexagon shape implies a blob storage or a data lake. That 1001 implies binary storage. And then on the far right, the consumers can be anything else, including another event hub or more storage. Those first two are the same as you see on the left. So I could be pulling something from an event hub, do something with it, and publish it to yet another event hub. Or I can go into a data lake. It can go into something as simple as email, queues, SQL, or reported live through Power BI. So in Stream Analytics, you create what's called a Stream Analytics job. You define the input, which again is one of the three: Event Hub, IoT Hub, or blob storage, which could also be a data lake. You can also, there are many outputs, far more outputs than there are inputs. And then you could develop a query that queries the input data to prepare the output data. Let's look at a quick example of this. Whoops, I ended that a little too soon, but let me go back out. This is our last topic. So let me close. No, I don't need to keep that. So I'm gonna go into Stream Analytics. I have no Stream Analytics jobs. Oh, quick question from Shelby. It says, is there a certification specifically on the topics you covered today? Yes, it is now called DP-203. Let me put that in here. DP-203 is the course and the certification. It will be live. Well, it's actually available right now, but it's not being made publicly announced until June 1st. So this is brand new. There was the DP200 and the DP201 that have now been combined into the DP203. So definitely everything I've covered today, except IoT Hub. Now the IoT Hub is more based on hardware and development, but the concepts would be the same once you capture the data. It does include the Event Hub, but the IoT Hub is a specialized version of the Event Hub, so that's a separate class. In fact, right off the top of my head, I think it's called AZ220. You might want to double check that, but definitely what we're covering today is DP203. Okay, so I'm going to create a job. We only got a few minutes left here. I'm going to call this JTK, what am I trying to call it? Stream job. Resource group, back in the same one. East US. And notice too, here's the hosting environment. Do you want to keep it in the cloud or do you want to push it out to an edge device? I'm going to push it down as low as possible. And that's it, create. So creating a new job that is going to be listening to whatever input I associate it with. Very quick creation because there's not much to it, but the power behind it is exceptional. If I go into inputs, this one job can be set to, notice here, I can put an event hub, an IoT hub, or blob storage. Now, because I did not create a hub yet, I'm just going to go ahead and choose blob storage. And this should answer your next question. It says, can we upload a directory like files? Yes, just like this. Put it into your data lake. Let's see, what's this alias? I'll call it my data lake. And what's the storage account? I've got one here already. It's already there. Managed identity. I don't need a pattern. I don't think I need a key. But this is basically describing what can I expect there. If you're going to say go to data FS, then I may need to create a path that says this will hold the JSON files that you're expecting. Because of course, if I'm going to query the data, I got to have an idea of what to expect. So I can still use a JSON file, or notice all these others: comma delimited, space, Avro, Parquet files. You can read those in as well. Let's go ahead and just okay, connection string, and then I got to pull in the connect. Okay, it already did it. Good. Save it. So now that's saying my job can read from my data lake. The outputs that I want to send it to, notice all of these different options that I have. If I say I wanted to go to CosmosDB, for example, let's say my output, blah, 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 I can send it to core, put it in my HR database that's already there, and employ, and then save it. So that means I can now have employee information coming in over some type of event hub or database, and I can drop it right into CosmosDB. Now, in between the input and output, this is where you have the power to say, okay, I'm reading it one way, but I'm going to redesign it or reshape it out a different way. So this is ETL. So if it's very simple, extract, transform, and load, and it's coming from an event hub, this is the easiest way to do it. You don't need Databricks, you don't need Data Factory, you don't need SQL Analytics. This is a very cheap, low-level way of transforming the data as quickly as possible, because usually events come in with very small sizes, but there's millions of them coming in constantly. Okay, guys, that's it. It's now 2 o'clock Eastern. That's a cram 3 hours. I hope you enjoyed it. I hope you get an idea of what fun you can have with all of these products. And remember, we looked at storage accounts, SQL databases, CosmosDB, Data Factory, Databricks, Synapse Analytics, Event Hubs, IoT Hubs, and Stream Analytics. A lot of stuff to learn, a lot of fun products to work with. So I hope you enjoyed it, and hopefully too, I'll see you in one of the classes. Please consider taking the DP203, the AZ220 for IoT, and ask for me personally, Tom Kinser. That's it. Have a great evening. Have a great weekend. Goodbye.